Hi, AP Physics. The next part of our notes and the next thing I want to investigate is what happens as we change different portions of the capacitance. So there's going to be a couple of equations that I'm going to write down. The main one, right, is our general equation for capacitance. So C is equal to the charge over the change in voltage. And if we have parallel plates, in the video, we should have seen that that equation is the area times epsilon naught over the distance between those plates. So using these equations, we can figure out how the capacitance is going to change as we change some of these variables. So what we're going to be looking at is a circuit comprising of a battery, positive side, negative side. This is just going to be some change in voltage. And then we are going to have parallel plates. My drawings are very accurate as always. Actually, I think those are pretty good. Nah, they're sort of okay. It's fine. So the two parallel plates have some area A, and they're separated by a distance of D. So what happens as we change some of these variables around? The first one that I want us to consider is what happens if we double the area? Will the capacitance increase, decrease, or stay the same? There will be no change. Well, we see that in the second equation, right, area, that lowercase a stands for area. If we doubled that, right, then we would get an increase in capacitance because more charge would be able to fit on that plate. What if we increase the distance between the two? Well, right, we're dividing by distance, so if we increase that, then the capacitance will decrease. This happens because the farther away, the weaker the electric field is going to be between those two plates. Let's try out the next one. What if we double the voltage? Well, if we double the change in voltage, we are going to be decreasing the capacitance. This occurs because the plates can only carry so much charge, and so when we increase the voltage, we're going to be decreasing the capacitance. All right, let's change now the area for number 4. So let's have the area. Well, right, we're going to be doing the exact opposite of number 1, so that's going to decrease. For number 5, if we have the voltage, well, that's going to do the exact opposite of number 3. So that's going to increase the capacitance. Number 6, what if we double both the area and the distance between the plates? Well, those two things are going to directly cancel, right? We double the area, we double the distance, we got a 2 on top, 2 on bottom. We're going to have no change. For number 7, if we double the charge, well, notice charge is on top, so that's going to increase the capacitance because we're also going to be increasing that electric field in between the plates. And then lastly, what if we have the area and double the distance? Well, both of these decreased the capacitance, and so it's going to do the same here, right? Since both decrease, it's just going to be even a larger decrease. All right, I hope that this little exercise of changing variables around give us a better conceptual understanding of what happens when we change these variables.